Our sun is a magnificent and powerful force. It is the heart of our solar system, a glowing ball of plasma that has been burning for over 4.6 billion years. Its gravitational pull keeps the planets in orbit, and its energy drives the climate and weather systems on Earth. It bathes our planet in life-giving light and warmth. Without the sun, life as we know it would not exist. Plants use sunlight to photosynthesize, creating the oxygen we breathe and forming the base of the food chain. The sun's warmth regulates our climate, making Earth a habitable place. But the sun is also capable of unleashing incredible bursts of energy. These bursts, known as solar flares, are sudden eruptions of intense high-energy radiation from the sun's surface. They can release as much energy as 1 billion megatons of TNT. These are solar flares, and the most powerful among them are called superflares. Superflares are rare but immensely powerful, capable of releasing energy equivalent to millions or even billions of atomic bombs. Imagine 1 billion atomic bombs detonating at once. The sheer magnitude of such an event is almost beyond comprehension. The energy released in a superflare could potentially disrupt the entire solar system. That's the kind of energy we're talking about. The impact of a superflare on Earth could be catastrophic, affecting everything from our power grids to our communication systems. Superflares are not just theoretical events. Historical records and scientific data suggest that our sun has produced superflares in the past. These events have left their mark on the geological and biological history of our planet. New research suggests they are more common than we once believed. Scientists are now studying the frequency and potential impact of superflares to better understand the risks they pose to our modern world. This is a sobering thought given the potential impact on our technology-dependent world. A superflare could knock out satellites, disrupt GPS systems, and cause widespread power outages. The economic and social consequences could be devastating. The sun holds secrets, and understanding these powerful events is crucial for our future. By studying solar activity and developing better predictive models, we can prepare for the potential impacts of superflares and protect our technological infrastructure. The more we learn about our sun, the better equipped we will be to face the challenges it presents. Deep within the sun, powerful magnetic fields twist and turn. These magnetic fields are generated by the movement of plasma within the sun's interior, creating a complex and dynamic environment. The sun's core, where nuclear fusion occurs, is the birthplace of these magnetic fields. As the plasma moves outward, it carries these fields with it, creating a constantly changing magnetic landscape. These fields can become tangled, like a rubber band stretched to its limit. The convective zone, where hot plasma rises and cooler plasma sinks, is particularly prone to this tangling. The constant motion and turbulence in this zone cause the magnetic fields to twist and turn, creating a complex web of magnetic energy. When these tangled fields snap, they release a colossal amount of energy. This process, known as magnetic reconnection, is one of the most powerful energy release mechanisms in the solar system. The sudden release of energy can cause solar flares, which are intense bursts of radiation that can affect space weather and communication systems on Earth. This energy bursts forth from the sun's surface, traveling at incredible speeds. Solar flares can accelerate particles to nearly the speed of light, sending them hurtling through space. These high-energy particles can reach Earth in a matter of minutes, causing geomagnetic storms and auroras. This energy, if directed towards Earth, can have profound effects. Geomagnetic storms can disrupt satellite communications, power grids, and even navigation systems. The beautiful auroras, or northern and southern lights, are a visible reminder of the sun's hidden power and its impact on our planet. Superflares are not everyday events. These massive eruptions are much more powerful than typical solar flares and can release energy equivalent to billions of atomic bombs. While they are rare, their potential impact on Earth is significant. They are thought to occur on average every few thousand years. Historical records and scientific data suggest that superflares have occurred in the past, and they will likely happen again in the future. Understanding the frequency and potential impact of these events is crucial for preparing for their effects. But even one superflare can release an octillion joules of energy. This is an almost unimaginable amount of power, capable of causing widespread disruption and damage. The energy released by a superflare is equivalent to the total energy output of the sun over several days. That's a 1 followed by 27 zeros, an almost unimaginable amount of power. This staggering figure highlights the immense energy contained within the sun and the potential impact of its hidden power on our planet. Understanding and studying these phenomena is essential for protecting our technology and infrastructure from the sun's powerful outbursts. In 1859, the Earth experienced the fury of a powerful solar storm. This event, now known as the Carrington Event, gave us a glimpse of the sun's raw power. Auroras, usually seen only near the poles, lit up the sky as far south as Cuba and Hawaii. Telegraph systems, the internet of their day, went haywire. Sparks flew from equipment, causing fires. Some telegraph operators reported receiving messages even though their systems were disconnected. The Carrington Event was a wake-up call, a reminder that we are at the mercy of the sun's whims. Today, our dependence on technology is far greater than in 1859. We live in a world where every aspect of our daily lives is intertwined with technology. From the moment we wake up to the sound of our digital alarms, to the time we spend scrolling through social media, and even the way we navigate our cities using GPS, technology is omnipresent. Our homes are filled with smart devices, our workplaces rely on complex computer systems, and our communication is instant, thanks to the internet. A superflare like the Carrington Event could have devastating consequences. The Carrington Event of 1859 was the most powerful geomagnetic storm on record, causing telegraph systems to fail and even setting some telegraph stations on fire. But back then, our technological infrastructure was minimal compared to today. If a similar event were to occur now, the impact would be exponentially greater. Scientists constantly monitor solar activity, but predicting such events with precision remains a challenge. Our power grids, intricately connected and vulnerable, could be crippled by the surge of energy. The electrical surge from a superflare could overload transformers and substations, leading to widespread power outages. Engineers work tirelessly to maintain and protect our power infrastructure, but the sheer scale of a superflare's impact could overwhelm even the most robust systems. The interconnected nature of our power grids means that a failure in one region could trigger a domino effect, causing blackouts to spread rapidly. Blackouts could cascade across continents, lasting for weeks or even months. Imagine entire cities plunged into darkness, with no electricity to power homes, businesses, or essential services. Hospitals would struggle to operate, food supply chains would be disrupted, and communication networks would be down. The economic impact would be staggering, and the social consequences could be even more severe, as people grapple with the sudden loss of modern conveniences and the uncertainty of when power might be restored. Satellites, orbiting high above us, are our eyes and ears in space. They play a crucial role in our daily lives, providing data for weather forecasts, enabling global communication, and supporting navigation systems. These sophisticated machines are equipped with delicate electronics that are highly sensitive to solar activity. The information they gather helps us understand our planet and the universe beyond, making them indispensable tools for science and technology. They are essential for communication, navigation, and monitoring our planet. Without satellites, our ability to communicate over long distances would be severely hampered. GPS systems, which we rely on for everything from driving directions to tracking shipments, would be rendered useless. Weather monitoring stations would lose their primary source of data, making it difficult to predict and prepare for natural disasters. The ripple effects of losing satellite functionality would be felt across multiple sectors, disrupting daily life and critical operations. A superflare could fry their delicate electronics, sending them tumbling back to Earth. The intense radiation from a superflare could cause satellites to malfunction or even fail completely. In some cases, damaged satellites might lose their orbits and re-enter the Earth's atmosphere, posing additional risks. The loss of these satellites would not only disrupt services, but also create a cascade of debris in space, further complicating future satellite launches and space missions. Imagine a world without GPS, satellite TV, or even accurate weather forecasts. The conveniences we take for granted would vanish, leaving us to navigate a world without the technological aids we've come to rely on. Emergency services would struggle to coordinate responses, businesses would face logistical nightmares, and individuals would find themselves disconnected from the global community. The challenge of adapting to such a scenario would test our resilience and ingenuity as we seek to rebuild and protect our technological infrastructure from future threats. Section 5. Eyes on a Billion Suns. To understand and prepare for superflares, we must look beyond our own star. Scientists are now studying sun-like stars across the Milky Way galaxy. By observing these distant suns, we can learn about their behavior, including the frequency and intensity of their flares. The universe becomes our laboratory. These observations provide valuable data, helping us to refine our models and predictions. Every star tells a story, and by listening closely, we can decipher the secrets of our own sun. Section 6. Secrets from Kepler's gaze. NASA's Kepler Space Telescope, a remarkable instrument that has revolutionized our understanding of exoplanets, has also provided valuable data on superflares. Kepler observed over 100,000 stars, capturing their light over several years. This treasure trove of data revealed that superflares are not as rare as we once thought. The Max Planck Institute in Germany analyzed Kepler's data and found that some sun-like stars produce superflares every few thousand years. This finding is significant because it suggests that our sun, too, is capable of producing these extreme events. Section 7. A symphony of starfire. Studying superflares is like listening to a symphony of starfire. Each flare produces a unique signature, a fingerprint that reveals its energy and intensity. By analyzing these signatures, we can learn to distinguish between ordinary flares and the rare, powerful superflares. The more we understand these signatures, the better we can prepare for the real event. Imagine a future where we can predict superflares with enough lead time to protect our infrastructure and technology. Section 8. The Vigil begins. The key to mitigating the impact of a superflare lies in early warning. The European Space Agency's Vigil mission, set to launch in the mid-20s, aims to provide just that. Vigil will orbit the Sun from a unique vantage point, allowing it to monitor our star's activity with unprecedented detail. Like a sentinel in space, Vigil will watch for the telltale signs of a superflare. If a superflare does erupt, Vigil will give us precious time, perhaps days or even weeks, to prepare for the onslaught. Section 9. Our solar future. We live in a technological age inextricably linked to the sun's power. As we venture further into space, our reliance on technology will only grow. Understanding and preparing for superflares is not just a scientific endeavor, it is essential for our continued prosperity and survival. The sun, our constant companion, is a source of both life and potential danger. By studying its secrets, we take our destiny into our own hands, ensuring a brighter future for generations to come.